This is lesson 9. Welcome back. I want to go over what we have learned so far and then use our knowledge to see how it applies in a new situation. This lesson should be short, so let's move on. So what have we learned so far? Firstly, numbers are not maths. Numbers are simply used to represent the size of the maths things. Maths or logic is used when we want to examine how our view of one thing matches our understanding of another. When we do maths, there are 3 situations we encounter. They are firstly, change one value into another. Secondly, find a missing value when that change is relevant. And thirdly, illustrate possibilities that use the specific changes. The last 2 are usually encountered in a description involving a practical setting. In 1, with the focus on the change process. In 2, we use a 3-step algorithm involving inverse processes. In 3, we draw a 2-dimensional diagram with perpendicular axes. These start with horizontally and finish with vertically. We will now apply all of this to the investigation of another type of change. We will investigate the consequence of the following observation. In a gathering, people are more comfortable when they have some space. A 1 metre square is effective. Now note, surface space is referred to as area. So type 1, a possible investigation is how many people can we fit in a square room. So I've made up a table. The room width relates to the number of people, and we want to see how we change our knowledge of a room's width into the number of people who would be comfortable there. We find that for a room width of 2 metres, 4 people would be comfortable. For a room width of 3 metres, 9 people would be comfortable. We can easily make more examples. What type of change is this? It is called squaring. Now for type 2, how big a room is needed for 9 people? Well, the width of the room when squared must give 9. So the width of the room will be the square root of 9. Notice the processing has moved in the equation. And the square root of 9 is 3. Now we can present this calculation more simply as notice we have abbreviated the process and we have an abbreviation for the inverse process. This is called squaring. This is the square root. So notice how the square root is the opposite or inverse of squaring. In maths, we use symbols to represent the processes of squaring and the square root. It's a good idea to make a list of the first 12 numbers and their squares, because they are commonly encountered in school maths courses, and you could even go beyond 12. Now for type 3, the illustration, we can use the samples generated earlier when I discussed type 1. Room width 0 would obviously not hold any people. Representing that situation, getting it ready for the graph, input 0 room width, output 0 people. Now if we change the room width to 1, the number of people would be 1. We express that as 1, 1. And then as we make the room wider, a width of 2 accommodates 4 people, a width of 3 accommodates 9 people, as we said previously, and you can make more examples. Now when we transfer that to a diagram, we have a series of points representing possibilities. When the room width is 3, the appropriate number of people is 9. When the room width is 4 meters, the appropriate number of people is 16. You'll notice that our points make a smooth curve, and this shape is described as a parabola. Notice how all three types of maths are consistent. In all of them, 3 meters wide is associated with 9 people. And here's a diagram showing that consistency. Type 1 is our examples, and in it 3 squared is 9. Type 2 is finding a missing value, and in this calculation we have concluded that 3 as a width is associated with 9 people. And in the illustration, type 3, the samples become a diagram which, for most people, gives a good overview of the possibilities. Now these arrows indicate there's an interconnection between the 3, and if you're working in any of those 3 types of maths, you might find you need to move to the other one to get some assistance in what you're doing. So there we've had a quick review of everything we've done, and we've applied it in a new situation. A short lesson. I hope you found that it was easy, and if so, you are making good progress. I'll see you in the next lesson.